Hi, this is Professor Tabatabaei from Department of Mechanical Engineering, York University in Canada. I was asked to talk about the Instrumentation and Measurement Technique course that I designed and developed in collaboration with Quanser. When I was first assigned this course, I took a while to think about it and see what is the best way of designing this course that's going to make it different from other instrumentation courses offered elsewhere. So obviously I looked at the existing solutions, courses offered in other universities in Canada and in the United States. And what struck me was that in most of these courses, the way experiential learning is implemented is that they pretty much have some labs. There are some well-defined problems. Students are given those problems. The students then have to play with equations, some variables, do some theoretical work, and do the lab, and hopefully learn something. But I was having trouble with this idea. And the problem was that in reality, in real life, that's not the type of problems that engineers face. Usually engineers face a need from the customer. If it's not even a problem, they have to identify the correct problem based on that need, and then they have to start from scratch, doing the design process and develop the product to solve that problem. So to me, it was obvious from the beginning that I need to have a project component in the course that would mimic this situation. So I wanted students to come up with a need and then give me a solution to solve that need. And then go through the process of design, through mentorship obviously, and create a product. So I was lucky that I was introduced to Quanser at the beginning of this process, and I had a lot of meetings with people from Quanser, from the highest level to level of engineers and technicians, and they helped me a lot in designing this course. So the project component was there, and we thought, what are the other components that we need to be able to support this project? Obviously, we need a theoretical part, so there were weekly lectures. I was covering the basics and fundamentals of instrumentation and measurement techniques with the help of some demonstration units that I developed, some of them myself and some of them in collaboration with Quanser. And on top of that, I needed students to have expertise in instrumentation, in making devices. Because if they want to do their projects, they need to know how to make, for example, signal conditioning circuits, right? So in collaboration with Quanser, we developed 10 labs that were dedicated to concepts of instrumentation and measurement. And this is very important because Quanser equipment that we purchased were not originally designed for such a course. They were designed for control courses. But the open hardware structure of Quanser equipment allowed us to manipulate them and build and create a whole new curriculum for instrumentation and measurement techniques. And I had weekly meetings with experts from Quanser, and we did this together, and students were very happy eventually. And on top of that, just to make sure that the students are moving in the right direction, we held mentorship sessions with students. We invited people from Quanser, engineers and technicians, as well as some faculty members from Department of Mechanical Engineering, to help a student to come up with the idea of their projects, and also to mentor them and guide them into the process of design and development. And eventually, in the end, we had the final exam in form of a conference-style event where students get to present their systems. And the beauty was that we had 16 groups. Each project was different from the other, because all ideas initiated from students rather than us giving them a well-defined problem and asking them to simply solve that. And I believe the students were very happy about the course, and looking to further improve the course and collaborate more with Quanser to create new labs on instrumentation and measurement. Thank you.